All right, welcome geology students to my first ed puzzle of the year. This is probably the second one I've ever actually made myself, so wish me luck. Um, so with this first lesson, well, you guys have learned about the scientific method, but this will be our first time actually exploring a little bit more about geology. And so the way I want to do this lesson is to start out by asking this question. What differentiates physical geology from the other sciences? So why are you in a physical geology class? Or maybe not why, but how is it different? And the answer, I think, the best way to answer this is to look at the hierarchy of matter. This is what I like to call it. I find that thinking of things in hierarchies makes them easier to understand because and I'll explain what a hierarchy is in a second, but this should help make the class flow a little bit easier and make more sense overall. But first, let's just remember, what is matter? So matter, I have the definition down here, and if it lets me pull it, well, we'll just do it like that. So matter is the stuff the universe is made up of. And matter always has mass. So that's something you need to remember. So when we're going to be dealing a lot with mass in this class as a scientific unit. We're going to measure mass and all that stuff. But matter is just the stuff. The other option really is energy. The entire universe is made up of matter and energy. So matter, we want to look at this hierarchy of matter. So what is a hierarchy? Well, a hierarchy, as I have here, is a system or organization in which people or things are ranked one above the other according to status, authority, or size. And in this case, we're going to be organizing it kind of by size, but really it's by mass. So the things with the smallest mass to things that have the largest mass. And so just as a simple reminder of what a hierarchy is, so you've probably heard of a power hierarchy. And this has nothing to do with this class, but I think it's a good way to understand it. You know, in most countries, just in general, humans, you have you have a lot of people who are not very powerful. So this is a lot of people. And then at the top, you have a few people who hold most of the power. This is a hierarchy, and you kind of think of it as a pyramid. So I don't really want to comment on the politics of this. I want to comment on how we're going to use hierarchies to explain geology. So let me kind of throw this aside really quick. I'm going to move all this stuff out of the way. And so it really all starts with the smallest. So we're going to start in this class by understanding the smallest form of matter. And just so you guys know, there are smaller forms of matter that really crazy, intense scientists are finding that are even smaller than these. But this class, we don't go any smaller than what are called the subatomic particles. And I apologize for my handwriting. It's pretty hard to write on this, but that's subatomic particles. Okay, and the subatomic particles are made of we have three subatomic particles, and you guys should know what these are. Well, hopefully this is a review for some of you. You have your proton, which is positive, and you can always remember that pro, positive. Your neutron, and your electron, which is negative. So you need to remember that, okay? And so then these subatomic particles will interact with one another in various ways. But they always tend to form the same type of structure. And that structure is going to look a lot like a solar system. And you guys have definitely, hopefully, seen this before. This is our nucleus, which holds our protons, and this can hold many protons, and our neutrons. And you have your orbitals, which hold electrons. So this is your nucleus. So hopefully this is review. And your orbitals, which hold your electrons. And what I actually just drew is the atom helium. But we'll talk about that more in a second, about how atoms are actually elements. But first I wanted to tell you guys, this is actually this solar system looking model where you have, maybe you could think of it as like the sun in the middle, right? Your sun in the middle and then your planets that orbit. I like to think of it, it looks kind of like a solar system. This is called the Bohr model. And this was discovered by a scientist named Niels Bohr. And before this, they really had a lot of different ways of thinking about subatomic particles, and then they finally did some experiments, which we won't talk about in this class, that's more for chemistry, and they figured this out. And just so you guys know, if you go into more intense chemistry, physics classes, you'll learn that this actually isn't the whole picture, especially for larger atoms with more protons in them. Oh, and sorry, I just noticed something. This is actually hydrogen, not helium. Anyway, there's something else called the quantum mechanical model, and it's much more intense, and we don't need to know about that. But that is something, if you go into the higher sciences, you will learn about. Okay, so how does an atom equal an element? Well, the truth is they're the same thing. An element is just a more specific type of atom. So it all depends on how many protons are in the nucleus. That will determine what type of element you are dealing with. So for example, I just said I messed this up. It's not helium, it's hydrogen. Hydrogen has one proton in the center. So one proton. Okay? So that is what an element is. An element is decided by how many electrons, protons, and neutrons are in this Bohr model. Well, not just the Bohr model, but just in the atom alone. So the more protons, the more neutrons, the more electrons, the different type of atom you have. And you guys can look at the periodic table to check that out, just how many we found. So elements, when elements, I'm just going to draw it as an E, combine with other elements, they form chemical compounds or molecules. And these chemical compounds will make many, there can be so many, really almost infinite variations of chemical compounds. And when we talk about chemical compounds, this is where we really split off into the different sciences. So if you have chemical compounds that form the DNA molecules that will eventually form proteins, then we're talking about life, and that is the study of biology. So you can see how that's a whole separate hierarchy in itself. But when these elements form natural non-living things, so you could have elements combining with elements, you could have chemical compounds combining with other chemical compounds, and usually they will repeat each other and form minerals. And I want to give you guys the quick definition of what a mineral is. So hang on, I gotta find it really quick. So here's the definition for you. Minerals are chemical compounds that typically have the same structure repeated over and over again in a structured, crystallized form. And so minerals, this is where we take on the path of geology. And so now you can see kind of where, okay, biology, that's more of a life science. It has to do with where chemical compounds start creating DNA molecules, proteins, and that's where we deal, and that can go into many different types of biological classes. Geology is where minerals are forming non-DNA molecules. They're naturally occurring, and minerals will eventually form rocks. And rocks will then go on to form, and let me move this up. Rocks will then go on to form larger geological structures like planets. like planets. And so this is where we're going to be sticking this year, sticking around. So is, you know, the rocks, the larger geological structure, and the planets. But that's not all. We also have, if you remember, this class starts with physical. So what is the physical all about? Well, let me give you a quick definition that I use for understanding what the study of physics is. And I have it over here, I gotta find it. Here it is. So physics is the study of matter and energy, or really it's energy in motion. So not only are we studying the geological structures of Earth, like rocks and how they're made, and what they're made up of, and how old they are, and all that good stuff, we're also going to learn about what happens when these things start moving around. And when they start moving around, you can see we get a lot of different, these are just two examples, earthquakes and volcanoes. What happens when these rocks start moving? Why do they start moving? If you didn't know, we live on giant rocks called plate tectonics, and they're constantly moving, causing destruction like this. So why does that happen? Well, that's the physics aspect. So that's why we call this physical geology. I did forget about one thing, and I want to go back to it really quick. We talked about bio, we talked about physics, and just so you know, if you're ever in a physics class, physics, they just study the motion of everything. From the very smallest to the very largest, they're learning how things move around. But I also forgot one other major science that you might take, and that's chemistry. And so chemistry kind of hangs out back here. What happens when chemicals bond with each other? And so that's where, you know, if you've ever taken chemistry, you learn a lot about why different elements bond with different elements and all that stuff. And we're going to take a quick second today to actually look at some. So in this class, you're going to notice we don't really touch a whole lot on biology in this class, maybe a little bit with ecosystems of living things and how geology affects living things. But we will touch on some biology and physics in this class. But I want to make sure that you guys understand a couple extra things. So what you need to know about subatomic particles, and this is kind of going back to the chemistry. So we're kind of finished with the hierarchy. You guys understand the hierarchy. Let me actually show you one more picture of the hierarchy that we deal with. So this is that picture. So this is a really good way of thinking of it. Atoms make up, if you need to pause the video to write some of this down, you can. This summarizes it really well. Atoms make up elements. Elements combine to form the natural compounds. Natural compounds and elements combine to form minerals. Minerals make up rocks. Rocks make up with the earth. And then you add all the physics aspect of all of those things moving around. Then you get physical geology. Right? So physical geology really is the study of all of these things and how they form and how they move around, because nothing is ever staying still. So to go back to what I wanted to move on to next, there was some extra things I wanted to add on to this lesson. So it's going to be a little bit of a longer lesson, but I think it's important for you to know. So let's talk about subatomic particles, the smallest particles, okay? We'll just say subparticles. And remember, those were your protons, electrons, and neutrons. The first thing you need to know is that protons are positive. You also need to know neutrons. Well, I'll just draw an N, because you know what it stands for. Neutrons are neutral, meaning they don't carry a charge. So this would be like a 0, this would be a plus, and then electrons are, and those first two are easy. P for positive, N for neutral. Electrons is the last one you just have to remember, they're negative. And they will have that negative sign. You also need to know that positives and negatives will really like coming together. It's called an electrostatic force. But if you have two positives, they repel each other. They do not like to be next to each other. Same with two negatives. If you have two negatives, they do not like being next to each other. They'll try to get far away. And this plays a role in some of the chemistry in this class. Oops, I keep talking that. So, you also need to know that atoms are made up of a combination of subatomic particles. We've already kind of looked at that. And that you guys looked at that Bohr model. So, what you also need to know is that the number of... So if I didn't make this clear earlier, the number of protons will always designate the atom. So I'll write that down. The number of p's, and remember those are positive, will always give you what type of element you are dealing with. So if you look at the periodic table, which you can take a second to do right now, you'll notice that 1 is hydrogen, and that hydrogen is 1 equals hydrogen. That's talking about how many protons there are. 2 in helium, and so on and so forth. So no matter what, if it has whatever number of protons it has, that is what element is. It does not change. You need to remember that. But what about the other subatomic particles? So what happens when the other subatomic particles, like the neutron and the electron, what if those... So normally the protons, neutrons, and electrons will all be the same. Well, sorry, this isn't normal. This is how we like to think of it. So when you look at an atom on the periodic table, we're assuming that they're all equal. There's the same number of protons to electrons to neutrons. So everything is balanced, so we call this a neutral atom. But in nature, things aren't always so nice. Sometimes you will have more or less neutrons than you do have protons. And sometimes you will have more or less electrons than you have protons. When you have more or less neutrons than protons in an atom, we call that an isotope. When you have more or less electrons in an atom, we call that an ion. And this is going to be really important with some of the concepts we learn in geology to understand what an isotope and an ion is. Because when we're studying geology, we have to look for these things to be able to determine, say, how old the Earth is, or what kind of minerals we're dealing with, what kind of elements we're dealing with. And so you can still have the same element, but it can have many isotopes, or it can have ions of itself. So the last thing I want to talk about is that the general rule of thumb with all, and this is kind of the chemistry of geology, is that all elements just want to relax. They just want to be stable. If you can remember this rule, this will help you understand most of the chemistry in this class. So, when something is an isotope or an ion, it does not necessarily want to be that way. It will give up energy it will lose some of its energy to become more stable, like a neutral atom. And so a really good example of this is something we'll talk about later, when isotopes decay, and I'm not going to talk about that now. We will talk about that more later, but that's when you get like radioactive decay. And so like you guys have probably heard of that. It's dangerous to be around like nuclear explosions because of radioactive decay. But in reality, there's minimal radioactive decay happening all around us that doesn't hurt us. But again, like I said, we'll talk about that more later. The last thing I want to focus on in this video is what happens when ions want to become more stable. And that's where you get what is called bonding between elements. And I'm going to make it really simple. There are 3 types of bonding. Okay. There is ionic, there is covalent, and there is metallic. At least these are the 3 types of bonding we're going to look at. The first 2 will always have to do with something called the octet rule. Meaning they always want to, elements will always bond together to have 8 electrons in their outermost shell. You don't really need to remember that, but it's important to note this is why they do it, because 8 electrons in their outermost shell will make them the most stable. This is just the general rule of chemistry. So ionic bonds, what they will do is they will take a positive ion, so this is some kind of positive atom, and a negative atom, and they will bond together. And because opposites attract, that's an ionic compound. They're very strong because opposites attract. Okay? Covalent, they also call molecular compounds. This is when a negative ion or element combines with a negative element. And what they do is they actually share electrons to try to get this octet. And this is not as strong because they're just kind of compromising, whereas the ones on top are really powerfully bonded together, really attracted to each other. Metallic bonding, what you need to know about metallic bonding is that when two metals bond together, you usually have to heat them up to bond them, and you probably kind of intuitively know this. What you're doing is you're creating a sea of electrons. And this is a bit different. It doesn't have to do with the octet as much. But what it does is it allows for electrons to move around freely. And this makes the atom more stable. When the electrons can move around more freely, it makes it a little bit more stable. And so some metals do like bonding to each other. When two different metals bond to each other, they form what are called alloys. And alloys are used a lot, and we'll be talking a lot about alloys in geology because they have a lot of, they're very useful to us. So like titanium, steel, stainless steel, those are alloys, or things that don't rust. So stainless steel, like I just said, that is steel iron with zinc in it. So it's two metals bonded together. One thing I forgot to mention up here is that metals have their unique properties of conductivity, and they're malleable, meaning you can kind of squish them down and mold them. Some metals are better at this than others, but it's because their electrons are moving freely. So I've covered a lot of topics in this video, but it's because I want to cover all the basics of the physical science you'll need to move forward. So if you need to go back, and I hope you took good notes, but if you need to review any of this stuff, we're also going to have a worksheet on it that should clarify a lot of it. Again, this is my second video on Edpuzzle, so I know it's a bit sloppy. I'll try to improve as we go. But thanks for watching. Okay, so I want to break it down a little bit further than just the geological hierarchy. Let's just look at the entire hierarchy of mass. So in this class, we don't go any lower than the smallest amount of matter we look at in this class is called the subatomic particle. And these are your protons, neutrons, and electrons. Correct? And so you guys have probably heard of these before. So the protons, neutrons, and electrons, you could think of, just for this class, you're just going to think of them as basically little units of matter flying around. Okay? And what happens is they tend to eventually combine together to form what are known as atoms. And an atom is when you have a nucleus. So we'll call this the nucleus, and you guys, I'm sure, have heard of this. And that's filled with your protons and your neutrons. Around the nucleus is the, we call these orbitals. So these are your orbitals. And these house the electrons. And so depending on how many protons there are, how many neutrons there are, and how many electrons there are, will give you the specific type of atom that we call an element. And you guys have seen these on the periodic table, correct? And just so you guys know, before I forget, this is called the Bohr model. This model that makes it look kind of like a solar system with the nucleus in the middle and everything else around it, the electrons floating around like planets. This is called the Bohr model, named after the scientist that figured this out. Because scientists didn't always know that this is what was going on with atoms. But anyway, elements are just more specific. Elements are more specific atoms. So you have these elements, and these elements, oops, I'm trying to move everything around here. These elements will combine. So when elements combine with other elements, let me reshape that here. So when elements combine with other elements, and there's so many variations, I'm making it very simple. What you get is you get a chemical, right? You get some type of chemical structure or some type of molecule, chemical molecule. And these chemical molecules can combine in different ways. And this is where the sciences kind of branch off. If the chemicals bind to form precursors to DNA, that's where you're going to get biology, the study of biology. So certain naturally occurring elements and chemicals that are formed by those elements will sometimes bond with each other, and they will form what we know as minerals. And minerals are chemical compounds that typically have the same structure repeated over and over again in a structured, crystallized form. So that is a mineral, and this is where we begin to follow the geology pathway of science. And so I wanted you to have a good understanding of this. The last part of this is, well, where does the physical and phys-geo come from? Well, physics is the study of all of these things as energy is added to them. So when we so the true definition of physics, I mean, there's a lot, and this is just how we're going to look at it in physical geology, is what happens when, so physics is really the study of what happens when matter and energy start acting together, or what happens when matter goes in motion. And you can see that in geology, we're focused on what happens when those rocks and the gigantic rocks beneath our feet, like plate tectonics and stuff like that, start to move. And what is the physics of that? And how do we understand it? And a lot of this is to understand, just how our world works, but it's also to keep us safe. And so when we study physics in this class, it's the physics of geology. So now I hope you have a better understanding of just what that means for this class. So if we go back